Hey guys, so today we are going to be focusing on forms, shapes, and variables when it comes to creative coding. I like to start with this quote by Paul Rand: design is relationships, that is where you start. So basically design is all about all these different shapes and objects that are working together on some sort of layout or canvas to create some sort of visual representation of what you're trying to achieve. So the basic relationships would be format. How big is your canvas? What size is your canvas? Shape. Are you going to be using rectangles or triangles, ellipses, or other shapes? Positioning. Where are you going to be placing those objects, those shapes on your format, on your canvas? Dimension. How large is the object going to be, or multiple objects going to be on the canvas? Then rotation. Do you want to rotate it? Is it going to be at 90 degrees, 45 degrees, or some completely random degree? So these are all the different relationships that you have to think about when you're coming up with some sort of design. So let's start with the format. So again, the format is just the canvas in which you are placing all these objects on. So you have to determine if it is a square, so all sides are equal. If it is horizontal, which gives more of like a natural feeling, kind of looking at the horizon, moving from left to right or right to left. Or is it going to be a vertical format? Vertical formats kind of stand out more than a horizontal format because we aren't used to looking up and down. We're used to looking left and right. It's more comfortable for us. So a vertical format really stands out to most people rather than looking at something horizontal. Horizontal just kind of blends in. A vertical format is really kind of aggressive and grabs your attention. So that's why most movie posters and most posters in general are in a vertical format rather than a horizontal format. So once you determine the canvas size and dimensions, then you can start playing with the shapes on the canvas. So are you going to be using circles and triangles and squares, or different, more complex shapes as well? How are you going to position those shapes on the canvas? How are they going to interact with each other? Are they going to overlap? Are they going to be far apart? Are they going to be perfectly centered? What's the decision behind that too? And then you also have to think about the dimensions of those shapes. Are they all going to be small? Are they all going to be large? Is it going to be a mix of large and small shapes? So now, rather than just looking at a circle and a triangle, if you put them together, overlay them, and change the dimensions a little bit, it starts to look more like an ice cream cone or a different object like that. So you could take simple objects like a circle and a triangle, combine them together to make a more complex shape, like in this case an ice cream cone. Then you could also play around with rotation. So in this case, if you rotate an ice cream cone upside down, then it looks like it fell on the ground. Then you could add a couple more shapes like an ellipse to it, so it looks like it's kind of melting away too. So these again are just two simple shapes: an ellipse, a triangle, and then rotation added to it, changing the dimensions and playing around with those shapes creates a much more interesting visual that really kind of tells a story rather than just simple triangle, simple ellipse, kind of floating around in space. So depending on how you're displaying the shapes and objects on the canvas, you can invoke different moods and add some sort of symbolism to your designs as well. So here we have a small rectangle, and by placing it in the upper right-hand corner and rotating it slightly, it kind of looks like it is jumping or bouncing and being very playful. Here we have another rectangle, and by making it much larger and wider, not rotating it and placing it on the base of the canvas, it looks very heavy. By making the rectangle very narrow and tall, we are creating a shape that looks very sharp. And by placing a small rectangle in the bottom corner of the canvas, it looks very timid and scared. So here we have the ice cream cone again, which is made up of a circle, a triangle. In this case, we're adding a rectangle to add that division. If we were to arrange and change the size of these elements, we start to get a very different object altogether. So on the left-hand side, it looks like an ice cream cone still. On the right-hand side, it kind of looks like a pin on a map or a road sign or something like that. So again, the objects are the same just by changing the position and the dimensions of these objects and how they kind of interact with each other, you get a very different object. Here are a number of different design examples that use these 5 basic relationships very well. So this is packaging design for a Dutch knife company. The triangle feels very sharp and is referencing the product inside. Here are 2 posters by Joseph Mueller-Brockmann. Both use simple shapes and text to represent movement as well as circular shapes to represent a record or music. Here's a poster by Paul Rand where he uses abstract A's and D's along with simple rectangles to create a bouquet of flowers. It's also a poster for the Art Directors Club, hence the A's and D's. Here's a movie poster by Saul Bass where he uses simple shapes to form a body for The Anatomy of Murder. These relationships can also be used with imagery. This is the classic ad from the 60s for the Volkswagen Beetle. Making the car very small on the canvas visually supports their tagline, think small. And this Joseph Mueller-Brockmann poster would have been very different if the 2 images have been reversed. If the motorcycle was in the background and the boy was in the foreground, it would be much less terrifying. So when it comes to creative coding, there are a lot of really great projects that use simple shapes and code to create these beautiful outputs. So this is a project by Rune Madsen called Tiny Artists 4 through 6. And he created this program that outputs these designs that is based off of these basic parameters and shapes. So on the left, they're all triangle based. In the center, they're all circle based. And on the right hand side, they're all rectangle based. But the program basically determines how many rectangles are going to make up the overall rectangle, how many triangles are going to make up the larger triangle, what color palette is going to be used for the output, and the size of the triangles inside the triangles or the circle or the rectangles. Once the output is complete and the design is completed, then the program actually deletes itself. So these are one-of-a-kind pieces that are generated by a program that was written by Rune Madsen. Here's another project by Jonathan Puckey. It's called Delaney Rasterization. It's basically using a Delaney triangle system to rasterize images. So it's basically taking images and applying triangles to the different components of that image to recreate the image using these triangles. This is a project by Field, which is a creative coding company, organization. It's called Communion, and it's a little video that I'll play real quick. Basically, it is showing an iteration of these programmatically created creatures made from these very simple shapes. So let's play the video. So each little creature is created generatively by the program. So every time this runs, there's going to be a new set of these creatures. But it's based off of simple parameters, so they all look similar. They're all within the same design family, but they're all incredibly unique too. So when it comes to these basic relationships and using it with code, we are going to be taking a look at format, looking at our canvas, we're going to be looking at shapes, we're going to be looking at the positioning of those shapes, the dimension of those shapes, and rotation of those shapes. For this class, we will be using P5.js as a programming environment, and we'll be using the P5.js web editor to program all of our sketches. To learn more about P5, if you go to the P5.js website, which is p5js.org, there's lots of documentation and reference pages on all of the different objects and variables and different code elements that you could use that come out of the box with P5. So it's a great resource. You should definitely check out the website frequently if you have any questions about any of these functions that we're going to be using. So these are the P5.js functions that apply to these 5 basic relationships that we just talked about. Let's take a quick look at each one of these, and then we're going to go into further detail. So the first is format. So with P5, there is a create canvas function, and this allows us to create a canvas of a certain size or dimension. The background function applies a background color to that canvas. For shape, there's a lot of different shape functions that come standard out of the box with P5.js. There's a point, line, rectangle, ellipse, triangle, quadrilateral, and then for any more complex shapes, you can use begin shape and end shape, and then add vertex points, or Bezier vertex points, or curve vertex points in between begin shape and end shape. Also, we'll be covering different modes. So there's a mode for ellipses and rect modes. So if you want to start drawing from the corner versus the center, you could change the mode. There's a fill for filling the shape with a color or grayscale. There's no fill if you want it to be completely transparent. There's stroke for, again, for the color, for the stroke color of the shape. No stroke if you don't want to have a stroke, and then stroke weight to change the weight of that stroke. For positioning, most of these shapes, most of the standard shapes like rect or ellipse, you can pass in a x and y coordinate for where you're going to draw those shapes. So the first 2 values in this function that you're going to pass in is going to be the x coordinate and the y coordinate for where this is going to show up on your stage, on your canvas. For anything more complex, like triangles or quadrilaterals, or using the begin shape and end shape and vertex points, you're going to have to use translate, which is going to translate that complex object to a different location on your canvas. Again, here, the only values that you're going to pass in is the x and y coordinate for where you want to translate that from. We'll get into this a little bit more in detail, but when you translate a more complex object, it's best to draw it starting at the 0, 0 point, and then translate it from that 0, 0 point to wherever you want it to be. Like the center of the canvas or the bottom, doesn't really matter. But it's always best to start drawing at the 0, 0 point, just for your own sanity. Push and pop is kind of like a way to group your code together. If you're translating one object, like if I have a rectangle and an ellipse, I just want to translate the rectangle, but not the ellipse, I would wrap the rectangle in push and pop and add the translate inside of that push and pop as well. So it would just translate the rectangle, but it wouldn't translate the ellipse, which was outside the push and pop. So it's a way to group bits of code together so it kind of stays separate from the rest. When it comes to dimensions, so again, with rectangles and ellipses, you would pass in that value to the 3rd and 4th area in the function. So again, the 1st and 2nd would be x and y, and then the 3rd and 4th would be width and height. Again, this is just for rectangle and ellipse. For triangle or quadrilateral, you're going to be using, or begin shape, end shape, you're going to be using vertex points. So you use the position of those vertex points to change the size of your particular complex shape. There is a function called scale, but I suggest that you try to avoid it as much as possible, because if you use scale, it can basically skew the dimensions of the object that you're scaling up or down, and it just looks bad and doesn't work very well. So I wouldn't recommend using scale, but that is a function that is available to you if you want to play around with it. Rotation. So you can rotate objects using the rotate function. To work with the rotate function, you have to use a value of pi. But if that is kind of complicated and no one wants to deal with pi, you can also use radians, the radians function within the rotate function. So if you replace this pi with radians 180, that'll be rotating the object 180 degrees. So variables. Variables are a way to create a word that represents something else, essentially. So width and height represent the width and height of the canvas when it comes to P5.js. So there are some variables that come standard with P5.js and always represent something. So width and height is always going to represent the width and height of the canvas. So whatever values you're putting in to create canvas are also going to be represented by width and height. Display width and height are also standard variables that come with P5.js, and that is the display screen that you're viewing on. It's width and height. You can also create your own variables if you wanted to create custom variables, and we'll talk about that next. So the great thing about P5.js is that it's built in JavaScript. And JavaScript allows us to use var, V-A-R, to represent a new custom variable. So if I wanted to do a string of text and create a variable for that, then I would say var and then give it a name. That name could be word in this case, equals hello world. And if it's a string of text, then it has to be in quotes like this. For integers or floats, it's the same thing. It's just var, give it a name, and then set it equal to a value. So var, in this case, whole number, whole num, equals 50. Or if you want it to be a decimal point, a float, then var decimal num equals 20.5. And again, it could be any name here that you want as long as it's one word. So I'm using camel case here. So it's a initial lowercase value for the first word and then uppercase for each one after that. So that's just an easier way to distinguish the difference between each word. And again, it's called camel case. And just like I said before, P5.js has variables that are kind of built into the program. So width equals canvas width, and height equals canvas height. So let's just look at this code real quick on the right-hand side. This is a P5.js web editor, which we'll explore very soon. So here we have var word equals hello world, var whole num equals 50, var decimal num equals 20.5. And the setup, this is where we put all of our setup information, like the create canvas, the canvas size, background color, etc. Anything that is going to load once is going to go in setup. So the create canvas, the canvas is going to be 150 pixels by 150 pixels. The background is going to be white. Rect mode is set to center, so the rectangle is going to draw from the center point out. Then we're drawing a rectangle. We're using the width and height variables that come standard with P5. So width is going to be equal to the width of the canvas, which is 150. Height is going to be equal to the height of the canvas, which is, again, 150. So if we do width and height, which is the width and height of the canvas, divided by 2, that's going to find the exact center point of that canvas. So we're drawing the x and y coordinate, the starting point for this rectangle, at the exact center of this canvas. And then we're using decimal num variable and whole num variable for the width and height. So the width is going to be 20.5 pixels, and the height is going to be 50 pixels high. So it's skinny and tall. And then we're using the print function, which is just going to print to the console down here. It's printing the word variable, which is hello world. So in the console, we see hello world when you run the sketch. Okay, so that is variables in P5. We will be using variables throughout the entire semester, throughout this entire class, so you're going to get very comfortable with them very quickly. All right, so let's talk about format. Again, this is the size and dimensions of our canvas, so what we are putting our design on, our shapes on. So for this, the functions that we want to focus on are create canvas. So we're creating the canvas size, which is going to be able to pass in a width and a height value. Then we could also change the color, the background color of that canvas using the background function. And by default, you could pass in one value for grayscale, and that value has to be between 0 and 255. So 0 is going to be black, and 255 is going to be white, and then everything in between is going to be a grayscale value. If you pass in 3 values, then it's going to be red, green, and blue, so RGB, for a color value. And again, each one of those has to be between 0 and 255. So 0 would be black, and 255 would be full red, full green, full blue. So why don't we go to our P5JS web editor? So if you go to p5js.org, so this is the P5JS website, and again, the documentation is fantastic. You can click through these and look at the references. There's a getting started section that's really helpful. There's libraries for anything that P5 doesn't out of the box cover. Someone probably has a library for it. There's examples, there's a learning section, and what we're really going to focus on right now is the P5JS web editor. So start creating with the P5 editor is the button that we're going to click on. So this is a P5JS web editing environment. So again, at the top we have our menu, so file for new, save examples, edit, sketch. So add a file, add a folder. If you want to upload files like fonts or images, etc. Then there's run the code and then stop the code. On the left-hand side, there's the play and stop button. So this is going to play our sketch and stop it. You can do auto refresh if you wanted to constantly refresh the preview. I usually leave it off because sometimes there could be bugs that can cause some issues. And then this is the name. If you click on that, you can change the name to whatever you want. And then here on the left-hand side is the sketch.js file, which is where we're going to be programming. There's a little arrow here if you want to look at the root directory. We have our index.html file, sketch.js, and style.css. We're mainly going to focus on sketch.js in this class. At the bottom of that, we have our console. So for any errors or any values you're printing out and to the console is going to show up here. So if it's an error, it's probably going to show up in red and tell you what the error is. And then on the right hand side here, this is our preview window. So this is when we run the sketch, this is going to be the visual interpretation of our code. So I'm also going to log in real quick. So you can log in using GitHub or I think Google, and then you could also create just a P5 email account if you wanted to. So once you've logged in, then you can save all of your sketches into your account and refer back to it, and also, and for the class, you could share it with the class each week, the projects that you're working on for feedback from myself and the class. So for this, whenever you create a new sketch, it gives you some code out of the box that you can start working with immediately. So for the first half of this class, we're actually not going to be using this function, the draw function. If you're doing anything that's interactive or has motion to it, then you're going to use the draw function. It's basically an infinite loop, just going to be looping through all your code infinitely. But for the first half of this class, we are going to be focusing on just the setup function. The setup function just runs once when you hit play. And because we're just going to be focusing on designing elements and creating posters and static graphics, we don't need the draw function. So we just need it to run once, and then that's it. So we could just go ahead and delete the draw function, and then in week 8, we're going to come back to it once we get into motion and animation and interactivity. So the function setup, it gives you a create canvas right away, which is very helpful. Basically, what we're going to do is determine the width and height of our canvas. So why don't we make this a different value for the width? So let's do 500 by 300 pixels. So we hit play. So I think the reason why we don't see anything is because we don't have a background. So let's go ahead and create a background color. And let's give it a grayscale value of 200. So now we have the canvas, which is 500 pixels by 300 pixels. And that canvas has a background color of gray, which is a 200 value. So if we did 255, that would be white completely. If we did 0, that would be black. And then if we did 3 different values, let's do 0, 255, and 0, that should be green. So 1 value is going to be grayscale, 3 values is going to be red, green, and blue. So if we do red and green, and it's yellow, and then let's do red and blue, should be like violet, I believe, purple. Okay, let's go back to grayscale. Let's just keep it simple and clean. So we have our canvas, we have a background color. Now we could start playing around with the different shapes and objects on that canvas. All right, so here are some of the simple shapes that we could play around with. So we have points, we have lines, we have rectangles, and ellipses. So these are what we're going to focus on first. So point is just that. It's a little point, a pixel essentially, just a dot. For that point, all you have to pass in is an x and a y value. So where on the canvas is that point going to live? For line, you can pass in 2 points, and then those 2 points are going to be connected to create that line. So we have an x1 and a y1, which would be 1 point of the line. Then an x2 and a y2, which would be the other point of the line. And then once those 2 points are created, then you can create the line to connect them together. For rectangles, we have an x and a y, so where we're going to be drawing this rectangle, and then a width and a height. So how big, what are the dimensions of that rectangle? Then for ellipse, it's the same thing as rectangle. We have an x and a y, so where are we going to draw this? And then width and height for the width and height of that ellipse. Okay, so why don't we play around with some of these? All right, so let's add a point. And for the points, all you have to do is an x and y value. Let's do 100 by 150 pixels. So 100 is the x and 150 is the y. And we're going to start in the upper left-hand corner. That's our 0, 0 point. So we're going to go over 100 pixels and down 150 pixels. So it's a little hard to see, but there's a little point right there, little dot. So we're going to get into this in a second, but I'm going to do a stroke weight so you can see it a little better. Let's do 10. There we go. So there's a bigger dot. So I increase the stroke weight to be 10 pixels. So this dot has a stroke around it that has 10 pixels. All right. So I'm going to delete that for now. We'll come back to stroke weight in a second. Okay, so there's our point. Why don't we do a line? So a line requires an x and y for the one point and then an x and y for the next point. So let's do 100 for the first point. And then let's do 200 and 200 for the second point. So the first point, we're going to go over 100 and down 100. And then the second point, we're going to go over 200 and then down 200. So this line should be at a diagonal, kind of in this area here. So let's try that. Cool. So we get a line. So this is 100 pixels by 100 pixels, and this is 200 pixels by 200 pixels. All right, so let's do a rectangle. So rectangle, the function is just rect, R-E-C-T. And the first value is going to be x and y value. So where do we want to draw this rectangle? Let's draw it at the center point. So let's use, I want to use those variables that come with P5JS for the width and height of the canvas. So to draw at the center, we could do width divided by 2 and height divided by 2. So this is going to start drawing that rectangle at the center point of the canvas. Then we can give it a width and height. Let's do 125 for the width and 150 for the height. Okay, looks good. All right, so why don't we do an ellipse? So an ellipse requires an x and y. Let's do at the center point again. Let's do width divided by 2 and height divided by 2. And let's make a circle. Let's do 75 by 75. So if the width and height are the same, then it's going to be a circle. If they are different, let's do 150 for the width, then it's going to be an ellipse. So use an ellipse to create a circle. It's just the same width and height. So we have points, lines, rectangles, and ellipses on our canvas. All right, so if you want to do something a little bit more complex than a line, rectangle, or an ellipse, then you could also play around with triangles and quadrilaterals. So triangles basically are very similar to lines. So as a quadrilateral, you pass in 3 points that are all connected. And with quadrilateral, you pass in 4 points that are all connected. So x and y1, x and y2, x and y3 for a triangle. So So that point connects to that point, connects to that point. Quadrilateral is the same thing. It just has 1, 2, 3, and 4. So it has 4 points on the quad. So let's go ahead and play around with some triangles and quadrilaterals. All right, so let's do a triangle first. So like I said earlier, it's definitely a lot easier to start drawing your more complex shapes like triangles and quadrilaterals, starting at the 0, 0 point. So the upper left-hand corner. Even if you want that shape to be somewhere else on the canvas, it's best to start drawing it at 0, 0 and then translate it to a different location. Mainly because just the math alone, kind of figuring that out, if you're starting at 0, 0, it's a lot easier to figure that out versus if you're starting at like 175 and 236. Just figuring out where the x and y coordinates for those points are based off of that coordinate is just more complicated than it's worth. So again, it's better to start at 0, 0 and then translate it after you've drawn it at the 0, 0 point. So let's do that. Let's draw a triangle. Again, the function is just called triangle. And then we're going to pass in 3 x and y coordinates to create this triangle. So let's do the first one at 50 and 0. We're going to do the second one at 100x and 100y. And then the third one we're going to do at 0 and 100 pixels. So 50x is going to go like there, and 0y, so it's going to be stuck at the top. Second one is 100, probably around there. And then y is going to be 100, so this is going to be like right there where the line starts. Then the third one is going to be 0 for the x, so it's going to start in the corner, and then you go down 100 there. So you should see the first point there, and then connects to that one, then connects to this one, and then back again. Okay, let's try that. Cool. So this is 50, 0, this is 100, 100, and this is 0, 100. So why don't we try a quadrilateral too? Let's try a quad. So again, this is just like a triangle, but you add another point, the fourth point, x and y coordinate. So let's just make it a little strange. Let's do 10 and 20 for the first point, 75 and 0 for the second point, 100, 100 for the third point. Let's do 0 and 80 for the fourth point. All right, so this is 10, 20. So x 10, y 20. This is 75, 0. X 75, y 0. This is x 100, y 100. And this is x 0 and y 80. So let's say we wanted to make something a little bit more complex that had more than 4 corners to it. So if we wanted to go beyond a quadrilateral, basically, you could totally do that. You can make any sort of complex shape that you want using begin shape function and end shape function. So this is basically just saying we are beginning to draw a shape here. We're beginning to draw a more complex shape here. That shape is made up of these vertex points, which is using this vertex function. And then you're basically just drawing a bunch of vertex points. And then at the end, when you're done, you say end shape. I want to end the shape now. So all of these vertex points are going to be connected. And it's going to be drawing a more complex shape based off of these vertex x and y coordinates. So connecting one vertex point to the next, to the next, to the next, to the next, to create this more complex shape. So why don't we go ahead and play around with this, and let's draw a little house in the corner here. All right, so for our little house, we're going to start with begin shape and end shape. And just like with triangle, quadrilateral, and any other more complex shape that you're going to be drawing, again, start drawing it at the 0, 0 point. It's going to save you lots of headaches. And then translate it to the position that you want it to be in. So let's go and create a begin shape. And then I like doing the end shape and then filling everything in with vertex points. I also like tabbing in, just it doesn't do anything to the code, it just looks a little cleaner. All right, so let's draw a couple vertex points and then create this house. So vertex point at 50 pixels and 0. A vertex point at 150, a vertex point at 100, 125, a vertex point at 0 and 125, another vertex point at 0 and 50, another vertex point. It's a little repetitive, but we're almost done, at 50 and 0. All right, so 50 and 0, again we're starting from the 0, 0 point, so 50 and 0, 150, 100, 125, 0, 125, 0, 50, and then back to 50, 0. Okay, let's see if that worked. Cool. So we got a little house here, stacked on top of our triangle and quadrilateral. Why don't we give it a little window too? Let's do a rectangle at the end. Let's say, so x would be 50, y would be, let's do 100, and width, let's just do 50 by 50. Width and height, 50, 50. Okay, so it's drawing it in from the corner. So let's fix that and do 25 for the x, and that's too far down, so let's do 30. See how that looks. A little big, let's do 50, and let's make the window smaller. 20 by 20. Yeah, that's kind of good. I like that. So we got a little window in our house. Cool. So as you can see, as we are going from the top down in our code, the top is going to be drawn first. So our point is on the bottom essentially, and then our rectangle for our window is on the top. So that's why the house is on top of the quadrilateral, which is on top of the triangle, etc., etc. So the last thing that's written in your code is going to be the last thing that's drawn. So it's always going to be on the top level. So if you want to play around with curves, you could play around with Bezier vertex points, which are a little complicated. So if any of you are comfortable with Adobe Illustrator and creating curves in Illustrator, it's basically the same idea, but you're using code to actually create it. So you have X and Y point for the first point, so where it's going to start, and then the second point is over here. So we have a vertex point here, in this case it's 0 and 50. We have the Bezier vertex value is going to be a value of the handle, one handle, the second handle, and then the position of the point where that is going to end. And based off of the location of the handles, it's going to create that curve. So you have to play around with the position of these handles to get the curve that you want. So it gets a little bit complicated. I honestly don't use this very often because it is kind of hard to just kind of understand, but feel free to play around with that. If you are interested in doing other more kind of basic curves in your shape, you can check out curve vertex function, which is just a lot easier to use than Bezier vertex. So here's a little animated graphic that kind of shows you how a Bezier curve works. And based off of where the handles are and where the point is, that's the shape of the curve that it's going to create. So here is a little example that we could play around with that is just creating a little curved shape at the top. So why don't we test this out real quick? Okay, so let's put this at the bottom. Let me just add some space here. So let's do another begin shape and end shape. And then let's do a vertex point of 0, 100. And then let's do a Bezier vertex point. And again, it's going to be the handles first. So 0, 100 for the first handle, 50, 0 for the second handle, and then 100, 100 for the point. So let's just play that and see what happens first. Okay, so we got a curve here. So a little hump. Okay, that's good. So far, so good. Let's do another Bezier vertex. 100, 100, and 150, and 200, and then 200 and 100. So again, this is the first handle, second handle, and then the point. Okay, let's do that. Okay, so we got a little bit of a wave going. And let's do another one. Bezier vertex. 200 and 100, 250, 0, 300 and 100. Let's play that. All right, cool. So we got a curve going. So let's try and do the base. Let's do a vertex point of 300 by 300. Another vertex point at 0, 300. Another vertex point at 0, 100. So back to where we started. Cool. All right. So I guess that wasn't too terrible. And then you could play around with the curve by changing the values here. So let's try 50 here. So it starts to get a little funky over here. So it's best to just kind of start playing with the values of the Bezier vertex points and then seeing what comes out. That's normally how I like to do it, but whatever is more comfortable for you when it comes to curves, go for it. Okay, so when it comes to ellipses and rectangles, there are functions for the modes for each one of these. So an ellipse and a rectangle can be drawn either at the corner or the center point. So by default, the ellipse is drawn at the center point and then out. And by default, the rectangle is drawn from the corner and down and to the right. If you wanted to override that, you can. So this is going to be the default for an ellipse. And if you wanted it to start in this area, then you could change the ellipse mode to corner, and that's going to draw the ellipse from here down versus from the center point out. Same thing with rectangle. By default, it starts from the corner down. If you wanted to draw from the center out, you can do rect mode center. So let's check that out here. Let's just draw an ellipse. Width divided by 2, height divided by 2, and 200 by 200. Let's do a rectangle. Width divided by 2, height divided by 2, and let's do 100, 100. Okay, so we have a circle, an ellipse, and then a rectangle. So if we wanted this rectangle to be centered on top of this ellipse, what we could do is say rect mode center. It's going to draw from the center out. And then if we wanted the ellipse to be drawn from the corner, we can do ellipse mode corner. And that's going to draw from the corner down. I think this has to be capital, all caps, but let's try corner. Yeah. So we get a little bit of an error message that corner has to be all caps. Okay. All right, so the next thing we're going to talk about is shape styles. So for any shape, we could apply a fill, no fill, stroke, stroke color, no stroke, and stroke weight. So fill is just going to be the fill, the color of the shape, the interior color of the shape. No fill, if you want it to be completely transparent, then you do no fill. Stroke color as well, you can change the stroke color. If you don't want to have a stroke, then you do no stroke, so there's no stroke around this shape. And then you could also change the stroke weight, which is the thickness of the line around the shape, using the stroke weight function. All right, let's go ahead and play around with that too. All right, so let's play around with these ellipse and rectangle that we just created. So above the ellipse, I am going to create a fill. And let's say we want this to be black. All right. So the ellipse is black, but the rectangle is also black. So this is kind of cascading styles down to anything that's below it. So this line here is saying fill black, and it's applying to ellipse, but it's also applying to rectangle. So to avoid that, you have to override this black with a different color for the rectangle if you want it to be a different color. So let's say we want it to be gray. So let's do another fill above the rectangle now of 200. So now the rectangle is gray and the ellipse is black. So let's play around with stroke color. Let's do a stroke color of white for the ellipse. So now both the rectangle and the ellipse have a stroke of white. So let's change stroke to, let's do 45 for the rectangle. So that's a dark gray for the rectangle and a white for the ellipse. Let's do stroke weight. Let's say 5. So now the thickness of the line around the shape is 5 pixels for both of them. Again, you could override the rectangle if you want. Now let's do actually, I'm going to comment this line out for the fill. Comment is 2 forward slashes, and then this line just kind of gets ignored. And I'm going to do no fill for the rectangle. So now we have no fill for the rectangle, so you could see through it. It's completely transparent, and you could see that bit of the ellipse coming through underneath it. Looks good. All right, so why don't we play around with translate? So translate allows us to move any objects from one position to another on the canvas. So this is great for more complex objects that we draw at the 0, 0 point, just because it's more complicated to draw somewhere else off the bat. So if we draw a triangle at the 0, 0 point, then we can translate that triangle to a different position using the translate function. So let's go ahead and try and translate some objects on our canvas to a different location. So let's try and translate the ellipse. So we do translate above the ellipse, and then let's translate it to 100, 100. So you can see the ellipse is here now, and it's at the center point now. If we translate it, it's going to move down 100 pixels into the right 100 pixels. So it starts in the center point, and then it's moving down 100 and 100. But it's also translating the rectangle. So just like with fill and stroke, this function is going to affect anything that's below it. So for that, we have a little bit of a fix, which is great. So if we wanted to translate an object that's like midway through our code but not affect everything else below it, then we could play around with push and pop. So again, this is kind of grouping bits of code together. So if you have push and pop, and then code inside and between push and pop, that code is just going to affect anything inside of push and pop and not anything outside of push and pop. So why don't we play around with that with our ellipse and our rectangle. So if we just wanted to translate the ellipse and not the rectangle, then we could say, okay, let's put this in a push. And I'm going to tab this over just so it's a little easier to see. And a pop. So now that this translate and this ellipse is kind of grouped together in push and pop, this translate won't affect anything below, or it shouldn't anyway. Awesome. So the ellipse is translated 100 by 100 down, but the rectangle is staying put. Okay, for scale and rotate. All right, scale and rotate. Scale, I'm actually not really going to talk about just because it's not a great function to use. It's better to change the dimensions based off of the function you're using. So if it's a rectangle, you want to change the dimensions using the width and height within that function, or the original vertex points for like a triangle or quadrilateral. When you use scale, it's going to skew and kind of modify in a bad way the actual shape. So this is the original rectangle on the left, and then on the right is the rectangle I'm scaling up. So scaling allows you to pass in a width and a height. So I am, this is basically 100, 1 equals 100%, 2 is 200%. So I'm doubling the height of this rectangle here. But it's also like changing the padding and the thickness of the stroke around it. So it does a lot of weird stuff that I wouldn't recommend. So yes, the scale function exists, but I would highly recommend avoiding it at all costs. For rotate, you can play around with the rotate function, and you can also use it in collaboration with the radians function. So by default, rotate allows you to pass in values that are based off of pi. So pi is equal to 100 degrees. So if you have pi in here, then it's just going to rotate at 100 degrees. If you have 2 pi, that's another kind of a variable that comes standard with P5. It's 360 degrees, so it does a full rotation. Then half pi is 90 degrees. But I usually, rather than using pi, I usually use radians because that allows me to plug in a value for the degree rather than playing around with pi, just because it's easier for me to understand personally. So let's play around with rotate. I'm not even going to show you scale just because it's very bad, but we can play around with rotate real quick. All right, so let's play around with rotate. So rotate is also going to rotate based off of the 0, 0 point. So it's going to be rotating here for this rectangle and ellipse, or for this ellipse. So it's going to rotate from here and then down like this. It's not rotating on the center point, it's rotating from the 0, 0 point. So let's just do pi first. Okay, so now it's rotating kind of off the screen. So it's like over here somewhere, off the canvas, because it's 180 degrees. Based off of the 0, 0 point. But as you can see, it's also affecting the ellipse, also affecting the rectangle at the bottom. So let's put this in this push and pop. Just like with translate, it's better to put rotate and translate inside of push and pop, so it just affects the functions and objects and shapes that you want it to affect and nothing else below it. So let's do that again, and the rectangle pops back on, but the ellipse is still probably over here somewhere off the canvas. So let's play around with radians instead of pi. So I'm going to do radians, and in here we could just do, let's do a very small value so we could see what's going on. Let's just do 1 degree. Okay, so that's 1 degree. Let's try 5 degrees. See how it's slowly going off the screen? Because it's rotating from this corner up here. So it's rotating like this around the 0, 0 point. So if we did negative, let's do negative 20, let's see what happens. So now it's coming back up. Again, it's rotating from the 0, 0 point. So this is rotating around that point. If you wanted to rotate around the center point, let's play around with the rotate for the rectangle here. So I'm gonna delete this. Let's play around with this rotate for this rectangle. So I'm going to do rotate and radians, and let's do 20. Okay, so again, this is rotating from that 0, 0 point. Because we are drawing it at the center point, let's try at the 0, 0 point. Okay. So that's rotating around the center point. So if we do 0, so it's basically not rotating at all, then we just get a little corner here. If we do 20, it's rotating 20 degrees clockwise. So if we wanted this to be rotating around the center point, but on the canvas, like in the center of the canvas, then we could play around with translate as well. So if we added in a translate above the rotate and translate it to the center of the canvas, then it'll rotate around its center point rather than the corner up here. So let's try 45 degrees now. It should be a diamond. Cool. So you have to start at 0, 0 essentially, and then translate it to where you want it to be, and then rotate it. So that's if you want it to rotate around itself. And just for good measure, even though there's nothing below rectangle, it's good to do push and pop. Also, a little handy trick, if you want to tab over multiple lines, if you do on a Mac, if you do Command and the right curly bracket, it will tab over for you. So that's rotate and translate. So pretty much always when you're using translate and rotate, you want to use push and pop matrix so it doesn't affect anything that you don't want it to affect. So if you want to do something a little bit more complicated and like make a more complex shape out of multiple shapes, here's the example ice cream cone using P5 code to create it. I will add a link to this code and to the code that we were working on in class today to the description in the YouTube video and on the class website. So feel free to check out that link and play around with this code. But basically here we have our canvas background color. We're not doing any strokes. We have a fill of 255 for the ellipse. So the ellipse is here. And we're using push and pop for the triangle, which we are translating to the center point and rotating using pi, which is 180 degrees. And then the rectangle here is just that little black rectangle to create that separation between the ellipse and the triangle. And again, I will share a link to this code and the code that we were working on in class to the description of the YouTube channel and to the class website. So just as an example for the Brockman poster, this is just simple shapes. So I recreated this using P5 as well. And again, it's just one large ellipse, medium ellipse, and a small ellipse to create this record. So I will also share that code for this particular project on the YouTube description as well as the class website. So for the in-class homework assignment, I basically just want you to play around with using these simple shapes in P5. And for now, let's just use grayscale. We're not talking about color yet, so let's just use grayscale values to create a poster inspired by your favorite film or TV series. So I want you to create something that is very simple, just using simple shapes, no text, no color, just very basic. And I want you to have a link to that ready to share on Slack during our next class meeting. So here's a little example. I'm a huge fan of the movie Big, and one of the scenes that everyone remembers from that is the scene where they're playing chopsticks on this massive piano in FAO shorts. So I created this poster based off of that scene, basically recreating the piano and then adding some little footprints on there. So this is kind of what I'm looking for, just like a very kind of abstract interpretation of the film or TV series that you choose. I also just found this randomly online. This is another good example of what you can do. So there's The Simpsons, there's Lost, there's Mad Men, there's 30 Rock, all using very simple shapes to recreate the idea behind that series or movie. So something like this without the text and without the color is what I'm looking for the assignment. All right, that is it for this class, for this video. So I look forward to seeing what you guys put together for this particular assignment. All right, thank you.